Welcome to Stocks in Motion project. In this video, I will take you through different components of the pipeline and provide an overview of how they work together to create a real-time stock market data processing engine. First, I will start by giving you an overview of the project and its goals, and I will take you through different technological stacks I have used in this project, including Python, Kafka, some AWS services like Catalog and Athena, and also EC2 instance. For I will mostly emphasize on what is the importance of real-time data and how it helps in real life. Next, I will show you the architecture diagram of pipeline, which will give you a better understanding of how different components fit together. I will discuss some challenges I faced during this project and how I overcome them. After that, I will take you through the code and directories which I have provided in my GitHub account, which will just explain how each module performs on specific tasks, such as data injection, transformation, and virtualization. Finally, I will wrap this project up with a small case study which I have written on how Spotify utilizes Apache Kafka for real-time data processing and personalized recommendation, as you all know. And I will also provide you with some additional resources and invite you to ask some discussion or which we can have. And so sit back and relax and let's dive in the project.
So let's first talk about the prerequisites for this project. The prerequisites are really simple. You just need an AWS account and you should know Python basics. And if you have this too, you're good to go. And as I said earlier, that I will be mostly focusing on the term real time streaming here. So what is the importance of it? So if I take a local example here, when you order food from Zomato, Zomato notifies us with the actual time. It changes on the scenarios, right, where the order is reached. So it gives us a real-time notification where your order is reached or not. In same case in Uber also. Also, there is one more thing. When we order from Amazon, you get notification that you have purchased this order. This order is shipped. This order is out for delivery. So all these things takes place real time. So certain when you click on certain event, which I will be talking further, when you create certain action, there has to be some notification to you for assurity, or we can say for credibility. And let's take an example of banking system. There are a lot of different application on stream processing. When you make some transaction online, and if the credit card company finds this faulty transaction, it is a faulty transaction, the company will give you a notification of it in real time basis. And one more thing, when actually we have faced this in phone pay, Google Pay, when you make a transaction, and if the money is deducted from your side, but the other side, your friend's account, the money is not showing. There is no message to him. So even there is 30 seconds to 1 minute delay here. So you get panic, right? You keep losing your mind. So this everything has to happen in real time basis, and that's it. So for this, we are using Kafka, and Kafka is. Let me show you an architecture diagram here. So we are going to use Kafka here for the most of for distributed our distributed environment actually. So what makes Kafka distributed? Let me show you what Kafka is actually first. So I have written some small information here. So Apache Kafka is a type of software that helps different computers programs to talk each other. It's kind of like a messenger. So you can think of Apache Kafka as a middleman here between two computer programs, allowing them to send messages. And this Apache Kafka can handle lot of messages at one time. So messages, events, this all are similar things. And one of the reason Apache Kafka is so popular that it is fast and it can handle lot of messages at once. It's often used for big data and real-time streaming application, which we are going to use. And also, Apache Kafka, like I said, it is distributed event store and stream processing platform. So what does distributed mean here? That Apache Kafka is designed to work across different computers or servers. So this allows large amount of data and processing power. And also event is basically if you do something, click on application like or like something or share something or social media. When you like your post on social media, when you share your post on social media, and basically everything where you click or we can say you share or anything. So this everything is recorded and this is used for various things. And event streaming means that Apache Kafka is used to stream simultaneously and means this data is sent simultaneously from one place to another. In case of Kafka, this data can be from of website clicks to sensor data from industrial machines. Um, we can say that the data can be from CCTV cameras for real-time basis, and that's all. Let's see the diagram of real-time. Like here is the example. For example, when user clicks on a button on website, that event might be sent to a data processing program like Apache Kafka, which can then process and analyze the event in real time. So by this, the organization can make quick decisions on this, and this is why Apache Kafka is used often in the organizations, and that's all. And you can read, you can pause, and you can read this all. So let's see the diagram of how Kafka works actually. So basically, there are components in Kafka. The major components are producer, um, the broker, and the consumer. And there are more, but we will be focusing on these three because that's all we need for this project. So producer, as we talked about the events, right? When we click on website, so anything which produces data, anything which produces data, we can say that it is producer. Where a car is connected to a smart system, as we see nowadays, some financial transactions of stock market, the hospital machines, and the shipments and the logistic process, all as we uh, consider it for Amazon example. So everything here makes an certain type of information. So this information is then sent to uh, Kafka. There is a middleman here between Kafka producer and consumer. It is a Kafka broker. So Kafka broker is nothing but a fancy word for. It is a basically type of server. So it's same. It is a cluster of different brokers, we can say. So what this will do, this will send data to. This will, as we see, the producer produces the data, and the broker will use this data in distributed manner, and then it will send to consumer, and we can then create reports on it. Um, we can create reports on it. We can see the logistic. We can see the insights of it in real time. We can also use the dashboard which is provided by Kafka. So that's all for this. So that what makes Kafka distributed. So all these things distributed. So we need someone to manage this, right? So there is a zookeeper also, which manages this distributed environment, which means this broker are just computers, by the way. The zookeeper will manage. So what does that mean? The zookeeper will make sure that all things are performing really well, running properly. So that's all. Let's focus on now the our project, actual project. So here I have made a short architecture diagram. As you can see, we have raw data here. So yes, as we said, we are going to use Apache Kafka, which is not installed on our local machine. We have used Amazon EC2 instance, which is an object storage, which will help us to store the Apache Kafka server and run at its full potential. And I have chosen a raw data here, which is a stock market data. You can choose any data, but I have chosen this because uh, to make it like a real life example. By the way, I have not taken the real time data, but we can do it by including an API. So if we want a real time data, we can just so there is an API also which will provide, and there is a our Indian site on National Stock Exchange, NSE, which provides real time data. If you want to use this for your project, you can. By the way, this the data is paid. That's why I haven't used it for the learning purpose. But you can have it. You can find the data. Yeah, here it is. Get under the get market data, daily market reports, paid real time data. So you can have it. Uh, I don't know what amount it is, but you can have it for your project. But for this project, I have considered a raw data, which is just uh, because I am more focusing on the whole concept of this data processing and what should a data engineer should know. So I have not considered a real time data here, but you can have it. So I have a raw data which will be then sent to an program which we have written in our Jupyter notebook. So what's Jupyter notebook? Jupyter notebook is a interactive environment where you can write Python code. So we have included our code, which is a producer and consumer code actually, which will help us to extract the data and send to our Kafka cluster. So our Kafka is installed on EC2 machine, and then it will send the data on to consumer. So consumer writes the data in a Amazon S3. So what's Amazon S3? Amazon S3 is a object storage. You can store whatever you want there. It is basically just a bucket. So and then crawler, AWS Glue, and Athena. This all are the AWS services which are provided by AWS. And what does this crawler do? It crawls the data from Amazon S3 bucket, and it makes in a particular manner. It creates a catalog, and using Athena, we can directly query on that real-time data, which will be sent from our raw data. So our raw data will be stimulated due to the Python code which we have written. It will send it to Apache Kafka, which is installed on EC2 machine. Then it will send the data to consumer. Consumer will write the data on bucket, our storage. Then you just have to run the crawler one time to create a catalog, and after that we are going to write some SQL queries to see the real action here using Athena. So that's all. So let's focus on our project now. I will be showing you how things work here. So I hope you understand the basics of Kafka here. So let's move to the execution part. So first we have to install the Kafka on EC2 machine as previously I said. So we will be focusing on firstly the middle part of here, not the initial one. You would able to connect it. So let's first move to our Amazon console, where I have installed. I have previously set up my EC2 instance, which you can see. So most of the things are default while doing this. So you can easily do this, and to save time and to show the quick demonstration I have done. So this is the instance. You can see the settings, and I have changed the public IP. You will able to relate this in next part. So first of all, we have to install Kafka, right? So how to do that? Just connect to your EC2 instance using SSH. You can do so. When you configure the instance, you will have a PIN key, which is a encrypted format for connecting your machine. So for that, um, this is the SSH path. So yeah, here we are. We are connected to our EC2 user with an IP. So if I do ls here, so as you can see, I have installed the Kafka previous for to save time. I have installed Kafka previously only. So how to do that? So it's really simple to install Kafka on EC2 machine. You can follow the repo I have shared, and I have written each and every step here. So first you have to install the Kafka, and then you have to extract it. So basically, it's an tar file. So we have to archive and then unzip it, and then after that, we know that Kafka runs on JVM, so you have to set path for Java virtual machine. So you can do that easily. So how to transfer anything from your local machine to our instance? So there is a software called FileZilla, which is open source, which is easily available. You can use that, and which I have used to move the files of you can download or you can move from your local machine to EC2 machine. So it's really simple, and this is the path I have shared of JDK, which I have installed. So after that, I have extracted the both JDK and the Kafka, as you can see here. This is a this is the zip file and this is the extract file. Same goes for Java. So I have extracted it. I have set the path for Java. If I have to check the version, you can check the version. So I have configured everything previously only to save time. So what after that? As we talked in the architecture diagram, we have to start the zookeeper first, because zookeeper is the manager, right? He is going to manage the brokers and the tokens. So how to run this? Just simply, so first of all, navigate to the Kafka folder where this all files are located. If I want to show you, here we are, the Kafka folder. We are into Kafka. So here we are. The Zookeeper is running. Note that we have to use multiple terminals. So first of all, we run the Zookeeper, which then after that we are running Kafka server. To do that, basically we want one more terminal, so we have to play with many terminals here. So I'm again connecting to my EC2 machine, and after that I am moving to Kafka folder and this command export Kafka help OPTS. So why this command? So let's not execute it previous first. You will get to know why this command is used. So here I'm running the Kafka server. So we get an error, right? The memory, something like insufficient memory. So you can read this on internet, but the easiest way to is allocate some memory or give this command, so there will be no such issue for the. So yeah, we can now easily run our. We will start our Kafka server in this terminal. Yeah, here we are running our Kafka server. So one thing I want to show you that here this is three. 0474 219. So what is this? So this is our public IP which we have changed. So here we have an so why I have used it's basically very easy. I have given the steps here. First of all, I have actually changed it so you are on your system here there should be a different IP. So why this issue is there? So when we will write our code in Jupyter Notebook, like here, which I have written. So when we are going to write our code to stimulate things, it won't be possible because the public IP we can't access. Sorry, the private IP. We can't access the private IP other than the network itself. So we can't access the our EC2 machine from the Jupyter Notebook from a local machine. I think you are understanding it. So for that purpose, I've written some steps where you have to change the private server and modify the server.properties file. So here it is server.properties file. You have to you can use Vim or Nano. Just move to this file and give your public IP. Just this IP. Paste that IP there, and that's all. So after that, I have edited some inbound rules and set the traffic to all. But make sure for learning purpose, I have done that. But we never have to set the traffic to all. So there are complications in that. So here we are running the Zookeeper. Here the Kafka server is running. So what's next? So yeah, we have to create a topic here. So to do that, we need one more terminal. So this file I was talking, advanced listener, which is in server.properties. We can change that, and after that, inbound rules, then create a topic. So to create a topic, just copy this command. I have given this repository in the description, by the way. So again, we need a terminal. Terminal. We have to connect. We are connecting. So total three terminals, one for Zookeeper, one for the Kafka server, and this is for to create a topic. So make sure that while creating the topic, we have to specify the uh, the public IP of our instance. Um, Create. Keep this 9092. It's the port number. Public IP. You can get the instance public IP by clicking on the instance ID. Just copy the public ID. Move to the console. And that's it. Yeah, good to go. So what it's showing? Then no, is it no first file? Oh yeah. Sorry for that. First we have to move to our Kafka directory and then create the topic. So it will take some time. So yeah, we have created the topic. So next thing, so we have created the topic here. After that, we have we can create a one more terminal or just use this. So let's start the producer. So I'm using the same terminal. Sorry for that. I have to change the IP here. So as you can see that I've settled down. So this is the zookeeper running and this is the Kafka server. If you little bit scroll up, you can see that here my public IP will be shown. Yes, here it is 54.266.4.135. This is the same IP which we have here. So that's all we want. We have to access that code from our Jupyter notebook. That's why we have done that. Let me just settle this properly. So zookeeper, Kafka server. Now we have to create a topic here. To do that, we need one more terminal. Again, one more terminal. Same process. We have we are in our Kafka directory and then topic. So we are creating here topic with name demo test. Make sure you are giving the proper IP. Ignore the warning, by the way. So here, we have created a topic. So now we will start the producer. Same terminal. No need. Again. So yes, the producer is running. Now we need one more terminal. Again, you have to log in, then Kafka directory. Then we have to run the consumer here. So let me just arrange this properly. This is zookeeper. We have zookeeper here. This is the Kafka server. This is our producer, and this is the terminal which we are in. Again, the same process. So yeah, you can see that something is happening in our Kafka server, right? So we have multiple terminals here. Don't get confused. So if I have to show you something, I will just type hey. You can see that, right? At right side, simultaneously you are getting the message. So we are doing this in real time. In real time, we can witness the thing right in front of you. You can type anything. It will just show up in the next terminal. So we have to automate these things. Why? Like, we can't do this every time, right? Open this file, open this that is directory, always log in. So we have to automate this thing. So I will keep the services running, and now let's move to the Jupyter notebook. So I have provided the code here, consumer and producer code. So it's very simple. I will show you. So this part, this middle part is all mostly done. So now we'll focusing on the initial stage here. So let's first write the code. Whether this BOTO3, you will get to know this. This is a S3FS package which I have included. Yeah, this is producer, this is consumer. I will close this tab. This is producer. So I will explain the code. So if you know basics of Python and pandas, this is very simple. So we have imported the libraries. Panda for reading the CSV file. So for this project, I have taken the raw data. Means you can have any, as I have said that you can buy the API, you can have the real-time data, but for learning purpose and everyone doesn't have money, so that's why I am using a historical data to just show the demonstration, and we are going to send data in JSON format. in our EC2 machine. So we want JSON library and we want this sleep. So why we need sleep? So we are going to give delay here 1 second. So why this is necessary? Because we don't have to crash our consumer, right? So I will be showing first of all. Um, we are just this is very simple code. Kafka producer, bootstrap server. Here we have to paste the uh, public IP, the same public IP of our instance. So we are sending this data in a proper format. So for that we need a visualizer, serializer, and it is our UTF-8 format. So that's it. This is our topic name, which we have given. This is our CSV file. This we have read the file. So sample. Why we have taken sample? Sample will just give random data. So we don't want our data to be in particular manner. We are just sending random data for this testing purpose. Same libraries in the consumer side. Yeah, this S3FS I was talking about. So you can import this library really easily. So it's S3FS lets you operate on the instance from your local machine. So it's really useful library. You can check it out. So I have imported it using pip. We have to install using pip obviously. Then creating consumer demo test bootstrap server. Here also we have to give the same IP, same. We are creating bucket, a bucket name. That's all. You can go through this code once again. So let me run this for you. Let me just stop it. One more thing before running this code, I have to tell you something. So we have covered this whole part. We have imported our CSV file, which contains the stock market historical data. We are automating that, stimulating that file using the Python code which we have written in Jupyter Notebook. The two Python code, the producer and the consumer. We are sending that code to the Kafka, and that code should be moved to the our bucket. So as I have said, bucket is a object storage where we are going to send our data. So I have done that previously. Can open the S3 bucket. So here my bucket is Kafka stock market. By the way, one more thing. When you are creating the bucket, you are creating the instance. Make sure you all are doing that at same region, which I have now Asia Pacific Sydney. So this is the data which I have sent from my local machine from the Jupyter notebook from this code. This is the previous data I have sent. We are going to operate on this. So let's move towards the next service which I have used. So just create a bucket by default settings and you're good to go. So I have run the crawler. This part has to be executed at once. So we will directly move to the AWS Athena, which is also known BigQuery, I think so in GCP. So you can directly query on our bucket. So let me show you something. Yeah, we are at our Athena console side. This is the editor. I have given the stock market our database and then our bucket also. So we need so why this stock market DB? So we need two buckets, one for storing the data which we are sending from Jupyter Notebook, the real-time data, and if we are executing query in Athena, there has to be one more bucket, as you can see here. So let me show you something. So yeah, let's proceed. So this is let me run the consumer too. Fine. Yeah, this you can see both the files are running. Now let me show you something really interesting. If I run this, I run it again. So you can see here, right? We are sending the real-time data at the consumer side. Just this all are value from the CSV file which we are sending. That's all I want to show you here. There was one more thing. If I remove this count, yeah, here you can see the data right in front of you. That's all. So, yeah, you can see. Actually, this I want to show you that you can see here. The data is sending simultaneously mm, from the consumer is receiving data simultaneously, and if I run it again, it will show 100. So the values are increasing. I am just using a simple SQL query here to count the value actually. So that's it. You are seeing the real-time thing here, 106. Again, I will run 102. So the data is really big. One more thing. So the data is simultaneously running here, as you can see. And if I need to show you something more, let me open the data for you. So how will that data look on other side? We can see. Just open a bucket, Kafka bucket. This is our bucket. Open any stock market data. Let's go anything. So if I download it, I'm going to I'm going to store it on desktop. And so that's it. You can see here that data is in JSON format, really organized, the high value lows. So it's working, right? My producer is working, consumer is running. You can see that data here, and also I can query top on that directly as I have shown here. So I run again. So you can see that data is really fast. Now we have 206. you can see this all things in real time, right? So that was the my motive in this video to show you. And that's it. Thank you for watching. I hope you found it informative and insightful. I have provided a link to GitHub repo in the description box below, where you can access the code, the architecture diagram, the dataset, and other resources. Please feel free to explore the repository, use the code for your project, and provide a feedback and suggestions to improve it further. If you have any questions, comments about this project, please leave them in the comment section. Thank you once again for watching. I hope you see you in my next project of 2